Welcome to Spring LIB.
Okay, I think what will help here is to draw potassium sulfate, right? So you've actually got a positive potassium ion, a positive potassium ion, and then a sulfate ion with a charge of -2. And what that looks like is a sulfur doubly bound to an oxygen, doubly bound to an oxygen, singly bound to a negatively charged oxygen, and singly bound to another singly negative oxygen. Okay, so this may help us, right? I mean, this is floating around in solution. Maybe I'll draw the other K plus over here just so it's more obvious that it's kind of hanging out next to that negative charge. Okay, so the questions are if potassium sulfate contains both polar covalent bonds and ionic bonds, and the answer is yes. These sulfur-oxygen bonds are polar covalent, and these potassium-oxygen bonds are totally ionic. So yes, one is true. Okay, 2. A covalent bond is formed through the transfer of electrons from one atom to another, and this is false. That's the definition of an ionic bond, in which neutral, let's say neutral potassium and neutral chlorine come together, and we could say this has one valence electron and this has 7 valence electrons. And through the transfer of this electron, single electron transfer, we get K plus, no valence electrons, and chlorine with 8 valence electrons, and their attraction is due to the opposite charge. So that definition given in 2 is the definition of an ionic bond, not a covalent bond. Question 3. When 2 atoms form a chemical bond, they lower the potential energy between the bonding atoms. And this is true. That's how bonding happens. If a bond can form, it is only because the energy of the 2 species will be lower than it was before. Right? That's basically like saying it's exothermic. Another example is if you've ever seen these charts of interatomic distance and energy. So imagine we have 2 molecules and they're separated by some distance, r in angstroms. And at far away distances, large r's, they have a high energy. And as they get closer and closer and closer, the energy reaches some minimum, after which it will increase, right? This is the potential energy. And that potential energy, when the bond forms, this is like saying infinite separation. This is 2 atoms, like right here. This R is far away, and this is close. And the potential energy is lowest when they're close.